Hello, today we're going to be learning about translations. Let's review. So far we've learned about reflections, rotations, and today is translations. So what you're going to want to do first is you're actually going to want to go to Canvas. Remember, you want to go to Pages, and this is Lesson 12, Translations. So we're going to be able to identify and draw translations of polygons on the coordinate plane, and a polygon is just a closed shape. Okay, so you might want to try the do now. And then yesterday, these are the answers to yesterday's classwork. Remember, that's due next week, Friday, but you want to check over that. And then you'll watch a video and you'll go on Desmos and you type in student.desmos.com. You'll complete the activity there, and then you'll be responsible for practice L12. Pages 11 and 12. If you feel like you would like some extra practice to start studying for the exam, you want to go to IXL and you can do lesson 2, L2, and L4. All right, so that's an overview of what we're doing today. Let's go ahead and get started. So in this picture, what I can see is I can see a reflection across this axis right here. So that's an x-axis reflection. So the rule that I would write, if it's across the x-axis, the x stays the same and the y changes. All right, now if I wanted to find the coordinates of the image of ABC with these vertices after a 90-degree counterclockwise, so remember counterclockwise is going to turn to the left, and the rule is flip-flop the coordinates, change the sign of the y. So A prime, which is originally at 3, 4, would be at -4, 3. B prime would be at -4, -1. And C prime would be at -2, 5, but this 2 is going to change to a positive because it tells you here that the y coordinate goes to the opposite of what it originally was. And then you can graph that on your own. So a translation, this is not in your notes, but it is a transformation in which every point of a figure slides the same distance in the same direction. So for example, you always want to go from F to F prime, the letter without the prime to the one with the prime. And when you slide on a coordinate grid, you are going to go right some distance, and then you're going to go up a distance, okay? So it's extremely important to know what the distances are. So on a coordinate grid, when you move up and down, up is considered a positive change, down is considered a negative change, and this affects the y-axis. Okay. The other option is that you're going to move right and left. So if you move right, that is a positive change. And if you move left, that would be a negative change. And this would impact the x-axis, or the x-coordinate. Okay. And then just so you know a little bit about vocabulary, when the direction that you move a shape, so if I'm saying I'm going this direction right here, and it's a diagonal, I would call this a vector line. So that's describing the direction that the shape is moving. And an example is like any t-shirt design, you'll see this. Any pattern, wallpaper pattern, etc. You'll see translations all the time. And now if you look at how you write the rule, the way we write the rule is right here. You're going to take the x-coordinate and add or subtract some value, and then take the y-coordinate and add or subtract some value. And whether you have a plus sign or a minus sign depends on if you're moving up or down. So let's look at some examples, and then I'll tell you what your assignment is for today. So this is practice pages 11 and 12. This is number 1. We're going to do one way to write a rule is to actually explain where you're going to go. So this says we're going 2 units to the left and 2 units up. Okay? So if I'm moving to the left, that's my x-axis. And because I'm going left, sometimes I put a minus sign here and a plus sign here, and a plus sign here and a minus sign here to remind me. It's going to be x minus 2. And then I'm going 2 units up, so that's going to impact my y coordinate. So it'll be y plus 2. So there's a couple ways to do it. I could actually take the coordinates of s, subtract 2 from the x-coordinate, and add 2 to the y-coordinate. So let's see what that would look like. S is currently at 2, 2. So I could subtract 2 from my x-coordinate, and I could add 2 to my y-coordinate to give me s prime, which would be at 0, 4. Or I can simply just move the coordinate point on the grid. So I would start here, and I would move 2 left and up 2. And you can see that this is, in fact, 0, 4, which is what we got here. Okay? And I can do the same thing for r. So r is currently at 4, 0. I would subtract 2 from my x-coordinate and add 2 to my y-coordinate, because that's my rule. And I would get 4 minus 2, which is 2, and 0 plus 2, which is 2. So my new coordinate, r prime, would be at 2, 2. So if I go back 2 and up 2, you'll see, in fact, that that is, in fact, where it is. Okay, so t, I'm just going to move back 2 and up 2. And that should be here. And q, back 2, up 2 is here. And I should notice that my shape, what we say is it has the same orientation. It did not flip, it did not turn, it did not rotate. It is exactly the same shape. The only thing that happened is that it moved. And it moved left 2 and up 2. Okay? Let's try another example. This is number 3 on your paper. And this is another way where we can write a rule. And so what you should see is that the x, there's nothing going on there. So nothing's happening to the x. The only thing that's happening is this negative sign says we're moving down. So I'm going to take each coordinate and just move it down 7. Or, of course, I can do nothing to the x-coordinate and just subtract 7 from the y-coordinate. So, for example, the point u is at 1, 5. So u prime, I'm going to do nothing here, plus nothing, and I'm going to subtract 7 from the y. So I should be at 1, negative 2. And let's see what happens when I take the u. We'll go down 5, 6, 7. In fact, here I am at 1, negative 2. So there's u prime. For t, I'm just going to go down 7. I should end up here. I'm going to go down 7. I'm going to end up here. And I'm going to go down 7. I should end up here. Okay. So there you go. So either way, if you have a coordinate grid, you can just count the grid squares. If you are just given coordinates, which you'll see later, you can just add or subtract the rule to each of the coordinates that's specified. This is number 5. This is another way we write a rule. And so please remember that this is going to be x minus 2, y plus 0. Okay? So what I'm doing is I'm taking my x-coordinate and subtracting 2, and my y-coordinate is staying the same. So what I should be picturing in my head is that this is just going to slide to the left. Let's go ahead and look at coordinate c as an example. So c is currently at negative 2, 5. My x says I'm going to subtract 2 from my x, and I'm going to add 0 to my y. So c prime will now be at negative 4, 5. So let's look. If I move it back 2, sure enough, that's at negative 4, 5. Okay? So I'm just going to do it the easy way for the other coordinates. I'm just going to go back 2, back 2, back 2. And so my new shape has now got the same orientation. It has not flipped, rotated, but it is just slid over to the left. Okay. For examples, for practice problem 7, you have to write the rule yourself. So remember, for number 7, you always want to start at h, and then you're going to count right and count up. And what you should notice is that it's x plus 3, y plus 3. So for number 7, that's how you write your rule. You start at h and you go to h prime. You always start at the number without the prime because that's your pre-image. And then you're going to go to the one with the prime. That's your image. Okay? So I'm not going to show you that example because I think you can figure that out. All right. So what you're responsible for today is you are responsible to go to do your Desmos activity. This is an assignment, so you want to go to student.desmos.com, and depending on which block, this is the code you type in. All right, remember, you continue without signing in, and then it'll prompt you to put in a code. Make sure you put in your first name and your last initial when you do the Desmos activity. All right. You're also responsible, so this is the first thing you're responsible for to practice. The second thing you're responsible for is page 11 through 12, numbers 1 through 12. Okay? And this is in Packet. Right? Okay. So those are the two things. And of course, you can do those IXL. If you go back to Canvas, you can see that you can also do IXL activities at the very bottom if you want some extra practice, okay? And this is also an opportunity to go back and review some of the other things that we learned in class. All right.